Hello everyone, I am Dr. Ranganath Haridas, working as Assistant Professor in SVERI's College of Engineering, Pandharpur. Today we are discussing one topic related to physics, that is gravitation. So in this video lecture, we are trying to cover the basic terms and equations related to gravitation. That is the first half, we can say. And in second half, we will complete different MCQs and numericals. So let us start discussing the gravitation. So in this topic, if we consider different points, so it starts with the Newton's law of gravitation. So one by one we have to cover these points. So let us start with some definitions. We will discuss it one by one. First is gravitational field. So what is meant by gravitational field? A region or space around body in which gravitational force is experienced by other bodies is called a gravitational field. What is meant by gravitational field? A region or space around body. So whatever that gravitational field is occupied, it is related to that region or space around that body in which that gravitational force is experienced by other bodies. Means, for example, planets, if we consider. So for example, Earth, if we take, so that region or space around that body, that is Earth, in which gravitational force is experienced by other bodies like Moon, that is the planet of Earth. So that experienced gravitational force around that body is called as it's a gravitational field. Now let us move to next point, that is Newton's law of gravitation. So we read it first. Newton's law of gravitation states that every particle of matter in the universe attracts every other particle with a force which varies directly as the product of their masses and inversely as the square of distance between them. So it acts along the line joining the two particles, which is given by capital F, which is equal to gmm divided by r square, or simply mg, or we can write g is equal to gmm upon r square. So let us check this in Newton's law of gravitation. So what we have read, that is simply nothing but, if we consider the two particles of matter, then they attracts each other with a force which varies directly as a product of their masses. Means it is directly proportional. Product of their masses means capital M into small m in this equation we are showing, and inversely adds the square of the distance between them. Means if we consider the distance as small r, so square of the distance between them, that is r square. So we are writing that equation as capital F is equal to gmm upon r square, and in terms of small g we are writing that equation as gmm upon r square, same thing. So let us discuss in Marathi. ग्रॅव्हिटेशन हा पॉइंट आपण डिस्कस करत आहोत. आपल्याला माहिती आहे की वेगवेगळे जे फोर्सेस आहेत त्यातलाच एक ग्रॅव्हिटेशनल फोर्स आहे. इट इज कॉल्ड एज वीक फोर्स, वन ऑफ द वीक फोर्स. तर ग्रॅव्हिटेशनल फील्ड म्हणजे काय, आणि ऑफकोर्स ग्रॅव्हिटेशनशी रिलेटेड जेव्हा आपण बोलतो त्यावेळेस आपल्याला न्यूटन्स लॉ ऑफ ग्रॅव्हिटेशन स्टार्ट करावी लागते. तर पहिल्यांदा आपण हे बघू की ग्रॅव्हिटेशनल फील्ड म्हणजे काय. रिजन और स्पेस अराउंड बॉडी, म्हणजे ती जी बॉडी आहे, फॉर एक्झाम्पल जर अर्थ किंवा एखादा प्लॅनेट असेल तर त्याच्या आजूबाजूची जी जागा किंवा जो स्पेस असेल in which gravitational force is experienced, त्या जागेमध्ये किंवा त्या रिजन मध्ये जो ग्रॅव्हिटेशनल फोर्स अनुभव केला जातो कुणातर्फे, बाय अदर बॉडीज, म्हणजे बाकीची ज्या बॉडीज असतील, म्हणजे फॉर एक्झाम्पल अर्थ आणि मून जर आपण एक्झाम्पल कन्सिडर केलं तर अर्थ जो ग्रॅव्हिटेशनल फोर्स आहे तो एक्सपिरियन्स करतोय, कोण करतोय, मून. आणि तो जो ग्रॅव्हिटेशनल फोर्स आहे त्या पर्टिक्युलर स्पेस मधला त्याला आपण काय म्हणतो, ग्रॅव्हिटेशनल फील्ड. त्यानंतर आपण काय चेक केलं, न्यूटन्स लॉ ऑफ ग्रॅव्हिटेशन, ज्यामध्ये डेफिनेशन काय सांगते, न्यूटन्स लॉ ऑफ ग्रॅव्हिटेशन स्टेट्स दॅट एव्हरी पार्टिकल ऑफ मॅटर इन द युनिवर्स अट्रॅक्ट्स एव्हरी अदर पार्टिकल. म्हणजे काय, तर युनिवर्स मधला जो पार्टिकल आहे, इच अँड एव्हरी पार्टिकल मॅटरचा, तर तो काय करतो, अट्रॅक्ट करतो कशाला, एव्हरी अदर पार्टिकल विथ ए फोर्स, एका फोर्सनं तो काय करतो, त्याला अट्रॅक्ट करतो, विच व्हॅरीज डायरेक्टली, तर तो व्हॅरी होतो, चेंज होतो डायरेक्टली, कशा कशावर तो डिपेंडेंट आहे, ॲज द प्रॉडक्ट ऑफ देअर मासेस, म्हणजे त्या दोन पार्टिकल्स जे मास आहे त्याचा गुणाकार, अँड इनव्हर्सली ॲज द स्क्वेअर ऑफ डिस्टन्स बिटवीन देम. इनव्हर्सली म्हणजे काय, तर डिवायडेड बाय त्याचे जे अंतर आहे डिस्टन्स, तर त्याचा जो स्क्वेअर आहे तर त्याला ते इनव्हर्सली प्रोपोर्शनल असते. तेच आपण इक्वेशनच्या स्वरूपात खाली मांडलेले, इट ऍक्ट्स अलॉंग द लाईन जॉइनिंग द टू पार्टिकल्स, F इज इक्वल टू GMM अपॉन R स्क्वेअर, जिथे M आणि स्मॉल m म्हणजे काय, तर मासेस आहेत त्या पर्टिक्युलर पार्टिकलचे मॅटरच्या, आणि R म्हणजे डिस्टन्स आहे, इट इज इनव्हर्सली प्रोपोर्शनल, त्यामुळे डिवायडेड बाय R स्क्वेअर. आता बाकीचे जे कॉन्स्टंट आहेत ते आपण नेक्स्ट स्लाइडला चेक करूया. पुढच्या स्लाइडला जर आपण गेलो तर इथे वेगवेगळे छोटे पॉइंट्स आहेत, सो लेट अस डिस्कस. सो दिस capital G is nothing but universal gravitational constant. Its value is given, that is 6.67 into 10 raised to minus 11 Newton meter square by kg square. Its dimensions also given. The gravitational force is the weakest interaction between the particles. The gravitational force of attraction between the elementary particles is negligible when compared to the other nuclear forces. The work done by the gravitational force between the planet and sun is zero. The gravitational forces are conservative forces and attractive forces. Gravitational force is the weakest force in nature. It is about 10 to the power 38 times weaker than the nuclear force and 10 to the power 36 times weaker than the electric forces. So these are some basic terms in detail related to gravitational force. First, if we check, the value of capital G is given with its dimensions. Next point, if we check, so as I have told that it is the weakest force. This force is the weakest interaction between the particles. The next is the gravitational force of attraction between the elementary particles is negligible when compared to other nuclear forces. So as it is weakest, the work done by the gravitational force between the planet and sun is zero. So work done value is zero. The gravitational forces are conservative forces and attractive forces. Gravitational force is the weakest force in nature. So if we compare it with nuclear forces and electric forces, so it is much more weaker than other natural forces which are in existence. Okay, so let us discuss this. या स्लाइड मध्ये आपण काय चेक करतोय, तर काही बेसिक टर्म्स ग्रॅव्हिटेशनल फोर्सशी रिलेटेड, ज्यामध्ये आपण जी ची व्हॅल्यू जी आहे तर ती पहिल्यांदा मांडलेली आहे 6.67 into 10 raised to minus 11 with its unit and dimension. आताच आपण म्हटलं की हा फोर्स आहे तर तो वीकेस्ट फोर्स आहे. वीकेस्ट फोर्स म्हणजे काय, तर इंटरॅक्शन बिटवीन द पार्टिकल्स, तर ती जी आहे तर ती वीकेस्ट आहे. त्यानंतर आपण काय म्हणतोय, ग्रॅव्हिटेशनल फोर्स ऑफ अट्रॅक्शन बिटवीन द एलिमेंटरी पार्टिकल्स इज निग्लिजिबल. निग्लिजिबल आहे. जे आपण फोर्स ऑफ अट्रॅक्शन कन्सिडर करतो. वर्क डन आहे तर ते 0 आहे, 0 आहे. प्लॅनेट आणि सन मधलं आपण एक्झाम्पल घेतले सोलर सिस्टीमचं. ग्रॅव्हिटेशनल फोर्सेस आर कन्झर्वेटिव्ह अँड अट्रॅक्टिव्ह फोर्सेस. अट्रॅक्टिव्ह फोर्सेस आहेत. आणि सगळ्यात शेवटी आपण त्याला म्हणतोय की तो काय तर विकेस्ट फोर्स निसर्गामधला. जर आपण न्यूक्लिअर फोर्स आणि इलेक्ट्रिक फोर्स कन्सिडर केला तर त्या कंपॅरिझन ग्रॅव्हिटेशनल फोर्स जो आहे तर तो weakest आहे. Okay, so let us move to the next slide. So in this we are checking what is meant by gravitational intensity. So first we read it. The strength of gravitational field at a point is the measure of gravitational intensity at that point. So it is related to strength of gravitational field at a particular point. Next, the intensity of gravitational field at a point at distance r from center of the body of mass m is given by, so it is given by capital E is equal to F divided by m. So if we use the previous equations, so it becomes simply capital G into capital M divided by r square, or E is equal to G. The unit of intensity of gravitational field is Newton per kg and its dimensions are given, that is m0, L1, t minus 2. The value of intensity of gravitational field is 0 at infinity. So these are the points. Let us check one by one. So gravitational intensity is nothing but the strength of that gravitational field at a particular point. That is called as gravitational intensity. How we can determine it? So if that the intensity of gravitational field at a particular point at a distance r from the center of body, if we consider mass as small m, then it is given by capital E is equal to F by m. After solving, we are getting E is equal to G. The unit is given with dimensions, and the last point is the value of intensity of gravitational field is 0 at infinity. This is another definition. आपण काय चेक करतोय? ग्रॅव्हिटेशनल इंटेन्सिटी. ती जी ग्रॅव्हिटेशनल इंटेन्सिटी आहे तर ती कशा संदर्भात आहे तर ती स्ट्रेंथ आहे. द स्ट्रेंथ ऑफ दॅट ग्रॅव्हिटेशनल फील्ड, ती जी काही तीव्रता किंवा स्ट्रेंथ आहे ज्याला आपण इंटेन्सिटी म्हणतो, तर ती त्या पर्टिक्युलर पॉइंटला आपण मेजर करतो आणि त्या पॉइंटची जी ग्रॅव्हिटेशनल फील्डची स्ट्रेंथ आहे त्यालाच आपण काय म्हणतो तर ग्रॅव्हिटेशनल इंटेन्सिटी. ती जी इंटेन्सिटी आहे त्याच्यासाठी जर आपण पॉइंट कन्सिडर केला, डिस्टन्स r सेंटर ऑफ द बॉडी पासून जर कन्सिडर केला आणि मास जर स्मॉल m आपण कन्सिडर केला, तर व्हॅल्यू येते E is equal to F by m. After putting the values, we can get the value as E is equal to G. Units and dimensions are given, and the value of intensity of gravitational field ची जी intensity असते ती 0 असते at infinity. Okay, so we move to the next one. Next point is acceleration due to gravity. So let us check these points one by one. It is defined as the acceleration set up in a body while falling freely under the effect of gravity alone, which is called as acceleration due to gravity. The value of G is 0 at the center of Earth and at infinite distance. Next, the value of G on the surface of Earth is 9.8 meter per second square, and near the equator it is 9.78 meter per second square, and at poles 9.83 meter per second square. Next is relation between small g and capital G. So weight of the body is equal to gravitational force acting on that body. So how we can measure the weight of the body is nothing but gravitational force which is acting on that body. It is given as mg is equal to gmm upon r square. That equation we have already checked. So let us discuss this. Acceleration due to gravity, that is small g, everyone knows. But how we can define that? It is defined as the acceleration set up in a body. So acceleration which is set up in a body, what is the condition? While falling freely under the effect of gravity alone. So when that body is falling freely, of course the condition is only gravity affects on that free falling. So that is called as acceleration due to gravity. Its value is 0 in both cases, that is if we consider center of earth and at infinite distance. Its value on the surface of earth is 9.8 meter per second square. At equator its value is 9.78 and at poles it is 9.8. If we look the relation between the small g and capital G, that is weight of the body, is nothing but gravitational force acting on that body. So it is given as mg is equal to gmm upon r square. So let us discuss in Marathi. Acceleration ड्यू टू ग्रॅव्हिटी म्हणजे स्मॉल जी आपण इथे डिफाइन करतोय. कसं डिफाइन करतोय तर ऍक्सिलरेशन जे सेटअप होतं त्या बॉडी मध्ये कंडिशन काय तर ती फ्रीली फॉलिंग म्हणजे ती खाली पडत असताना पण त्याच्यावर फक्त कशाचा इफेक्ट असला पाहिजे तर फक्त ग्रॅव्हिटीचा इफेक्ट असला पाहिजे. त्यावेळेस आपण ही जी ची व्हॅल्यू कन्सिडर करतो. अदरवाइज वेगवेगळे इफेक्ट्स आहेत, एअर मीडियम असेल, रेजिस्टन्स असेल, तर बाकीचे जे इफेक्ट्स आहेत ते कन्सिडर न करता जर आपण ही व्हॅल्यू काढली तर त्या व्हॅल्यूज खाली दिलेल्या आहेत. सेकंड पॉइंट काय सांगतो की या जी ची व्हॅल्यू म्हणजे ऍक्सिलरेशन ड्यू टू ग्रॅव्हिटीची जी व्हॅल्यू आहे तर ती शून्य असते. कुठे तर सेंटर ऑफ अर्थ, आणि जर डिस्टन्स खूप असेल दॅट इज इनफायनाइट तर जी ची व्हॅल्यू काय असते शून्य असते. आता ही जी जी ची व्हॅल्यू आहे ती पृथ्वीच्या वेगवेगळ्या भागात वेगवेगळी असते, स्लाइटली व्हॅरी होते. 9.8 ऑन द सरफेस ऑफ अर्थ, त्यानंतर इक्वेटरच्या जवळ असेल तर 9.78 आणि पोल्सच्या जवळ असेल तर 9.83. रिलेशन जर बघितलं स्मॉल जी आणि कॅपिटल जी मधलं तर weight of the body is equal to gravitational force acting on that body, that is mg is equal to gmm upon r square. So go to next one where this capital M is mass of planet, capital R is radius of planet, small m is mass of satellite acceleration, m is equal to mass of satellite, g is equal to acceleration due to gravity, therefore g is equal to gm upon r square. This is an acceleration due to gravity on the surface of planet of mass capital M and radius r. Okay, so if we check this equation, so each and every term is explained here in next slide. यामध्ये आपण काय म्हणतोय तर कॅपिटल M म्हणजे काय तर प्लॅनेटचं मास आपण कन्सिडर करतोय. कॅपिटल R म्हणजे काय तर रेडियस त्या प्लॅनेटची, M म्हणजे मास ऑफ सॅटेलाइट किंवा तुम्ही जर त्या प्लॅनेटचा को प्लॅनेट असेल समजा अर्थ आणि मून आपण कन्सिडर केलं किंवा या केस मध्ये प्लॅनेट आणि त्याचा सॅटेलाइट जर आपण कन्सिडर केला, आणि g इज नथिंग बट ऍक्सिलरेशन ड्यू टू ग्रॅव्हिटी. याच्यावरून आपल्याला हे रिलेशन मिळतं. सो दिस इज एन ऍक्सिलरेशन ड्यू टू ग्रॅव्हिटी ऑन द सरफेस ऑफ प्लॅनेट. त्या प्लॅनेटच्या सरफेस वर ती व्हॅल्यू g ची आपल्याला मिळू शकते. ऑफ कोर्स त्याचा आपल्याला मास आणि रेडियस या गोष्टी माहिती असतील तर आपण ते इझिली कॅल्क्युलेट करू शकतो. Now let us move to next one. Now next we are considering a case where the body is at height h above the planet surface. So at that particular height, how we can determine the things? So it is simply that just we are adding the value of height in that capital R, that is R plus h, and that is the change in the equation. So for a body at height h above the planet surface is given as mg is equal to gmm divided by in bracket capital R plus h, it's a square. So if you see carefully the figure, it gives the same thing, that is capital M and M, small and capital masses. R is radius and h is the height above the planet's surface. So after solving, m gets cancels and gh, that is acceleration due to gravity at particular height, is nothing but g into m divided by r plus h. It's a square, so that height matters, and we are considering these things. Thus gh is less than g, that is acceleration due to gravity decreases as we go above the planet from its surface. So if we compare these cases, that is gh upon g, that is r square upon r plus h square. So gh is nothing but g r square divided by r plus h, its square, or simply g is equal to gm upon r square. So let us discuss this. आपण आता काय केस कन्सिडर करतोय, तर एका पर्टिक्युलर हाईटला जी ची व्हॅल्यू काय असते, पण पर्टिक्युलर हाईटला म्हणजे काय, तर अबाव द प्लॅनेट सरफेस जो आहे तर तो आपण कन्सिडर करतोय आणि तिथून ती हाईट मेजर करतोय. सो इट इज गिवन बाय द इक्वेशन mg is equal to gmm upon r plus h its स्क्वेअर. यामध्ये चेंज काय झाला, मागचं जर इक्वेशन आपण बघितलं तर यामध्ये हे इक्वेशन आहे, तर या इक्वेशन मध्ये आपण काय चेंज केला, तर डिनोमिनेटरला रेडियस प्लस ती हाईट ऍड होते जी अबाव द प्लॅनेट सरफेस आहे. नेक्स्ट जर आपण त्याला सॉल्व केलं तर gh इज इक्वल टू gm अपॉन r प्लस h स्क्वेअर आहे. याचा अर्थ काय, तर जसं जसं हाईट वाढत जाते तशी तशी ऍक्सेलरेशन ड्यू टू ग्रॅव्हिटी ही जी व्हॅल्यू आहे तर ती काय होत जाते, कमी कमी होत जाते. तर तेच आपण इथे सांगितले. दस gh is less than g, that is acceleration due to gravity decreases. Acceleration due to gravity decrease होते as we go above the planet from its surface. जसं जसं आपण त्या प्लॅनेटच्या सरफेस पासून वर जाऊ तशी तशी ती व्हॅल्यू व्हॅरी होते. कारण का, सिंपल गोष्ट आहे की h जे आहे ते डिनोमिनेटर मध्ये जर ते वाढत जाईल, डिनोमिनेटरची व्हॅल्यू वाढत जाईल आणि g ची व्हॅल्यू कमी होत जाईल, as it is inversely proportional to each other. Next, variation of g just above Earth's surface. If h is less than r, then value of g at the height is approximately given as gh is equal to g into 1 minus twice h upon r. Variation of g with depth. If you consider the depth, so gd, that is acceleration due to gravity at depth, is nothing but given by gd is equal to g into 1 minus d upon r. So here we are adding these two equations which we are using in MCQs and numericals. Just above Earth surface जर आपण बघितलं तर त्यामध्ये काय h आहे तर ती खूप स्मॉल आहे r च्या कंपॅरिझन ना, त्यामुळे अप्रॉक्सिमेटली आपण ही व्हॅल्यू लिहितो. व्हेरिएशन ऑफ g विथ डेप्थ, खोली जर आपण कन्सिडर केली तर त्या खोलीला आपण काय करतोय, तर gd म्हणजे acceleration due to gravity at that particular depth, म्हणजे स्मॉल d ची व्हॅल्यू जी आहे तर ती आपण कशी काढतो, तर gd is equal to g in bracket 1 minus d upon r. तर हे इक्वेशन्स आपण चेक केले. नेक्स्ट, व्हेरिएशन ऑफ g on the surface of the earth. या केस मध्ये आता आपण काय बघतोय, तर ड्यू टू शेप ही केस कन्सिडर करतोय. व्हॅल्यू ऑफ g on earth surface varies because of two reasons, that is due to shape. First reason, so due to shape, earth is elliptical in shape. It is bulged at equator because of centrifugal force. Therefore, radius of earth is maximum at equator and minimum at pole, as g is equal to gm upon r square. So it is inversely proportional to r square for the same planet when mass is constant. Thus acceleration due to gravity is minimum at equator and maximum at poles. Let us check this. So variation of g on the surface of earth. Surface of earth, when we are considering, we know that it is a geoid shape. It is not a perfectly spherical. It is elliptical in shape, slightly pressed. If you consider one pressed ball, so it is slightly pressed one, elliptical in shape. So because as it is bulged at equator. The reason is centrifugal force. Therefore, a radius of Earth is maximum at equator and it is minimum at pole. So simply we are considering that G is inversely proportional to square of that radius. So for the same planet when mass is constant, thus acceleration due to gravity is minimum at equator and maximum at poles. याचा अर्थ काय तर सरफेस ऑफ अर्थ जर आपण कन्सिडर केलं व्हॅल्यू ऑफ जी साठी तर आपल्याला माहिती आहे की अर्थचा जो शेप आहे तो स्फेरिकल नाहीये इलिप्टिकल आहे त्याच्यामुळे इक्वेटरला सेंट्रिफ्युगल फोर्स मुळे थोडीशी जी रेडियस आहे तर ती जास्त आहे कशाच्या कंपॅरिझन ना पोलच्या रेडियस ऑफ अर्थ इज मॅक्सिमम ॲट इक्वेटर अँड मिनिमम ॲट पोल तर जर इक्वेशन आपण बघितलं तर त्यामध्ये लक्षात येते की ऍक्सेलरेशन ड्यू टू ग्रॅव्हिटी कशावर डिपेंडेंट आहे तर रेसिप्रोकल ऑफ डिस्टन्स दॅट इज रेडियस इट्स स्क्वेअर याचा अर्थ काय तर ऍक्सेलरेशन ड्यू टू ग्रॅव्हिटी हे काय असते कमी असते कुठं इक्वेटरला आणि जास्त असते कुठं तर पोल्स ओके सो वी मूव टू द नेक्स्ट वन दॅट इज critical velocity VC. So it is the velocity required to put the satellite into a circular orbit around the Earth. That velocity is called as critical velocity. Orbital velocity of a satellite when it is revolving around the Earth of mass capital M, radius capital R, at a height small h is given by m VC square divided by R plus h, which is equal to gmm divided by R plus h its square. So simply we are solving this equation, that is VC is equal to under root gm upon R plus h, or simply VC is equal to capital R under root g by R plus h. So let us check this critical velocity. Critical velocity म्हणजे काय? It is the velocity required to put the satellite into a circular orbit around the Earth. म्हणजे जेव्हा आपण सॅटेलाइट आपल्याला स्पेस मध्ये सेट करायचं असेल तर एक पर्टिक्युलर व्हेलॉसिटी लागते की ज्या व्हेलॉसिटीचा यूज करून आपण त्या सॅटेलाइटला सर्क्युलर ऑर्बिट मध्ये सर्क्युलर ऑर्बिट अराउंड द अर्थ म्हणजे पृथ्वीभोवती गोलाकार फिरण्यासाठी जी तिची कक्षा आहे सर्क्युलर ऑर्बिट तर त्याच्यासाठी तो सॅटेलाइट जो आपण सेट करण्यासाठी व्हेलॉसिटी लागते त्याला आपण म्हणतो क्रिटिकल व्हेलॉसिटी. त्याची जर व्हॅल्यू आपण parameters compare करून consider केले so it becomes VC is equal to R under root G by R plus H. Next, time period of a satellite. या केस मध्ये आपण time period बघतोय. It is the time taken by a satellite to complete one revolution around the Earth. So that time is given by 2 pi into capital R plus H, that is height of that satellite above the Earth's surface, divided by its critical velocity, that is VC. So after adjusting it we are getting 2 pi divided by capital R under root R plus H, it's a cube divided by G. So if we carefully check, so it depends upon the parameters. So as t square is proportional to R cube, so graph of t square and R cube is a straight line passing through origin. The slope of the graph is 4 pi square divided by gm, which is constant. So here we have to know this equation, that is t square is proportional to R cube. So we are using this value while solving the MCQs and numericals. Time period of satellite याचा अर्थ काय तर तो जो काही टाइम सॅटेलाइट घेतो कशासाठी तर एक कंप्लीट रिव्होल्यूशन अर्थच्या अराउंड रोटेट करण्यासाठी जो लागतो टाइम तर त्याला म्हणतात की टाइम पिरियड ऑफ सॅटेलाइट. तो कसा आपण कॅल्क्युलेट करतो सो कॅपिटल T is equal to 2 pi into R plus H divided by critical velocity. After solving we get this equation, and if we consider the relation between T and R, so it is T square which is proportional to R cube. T square हा R cube ला proportional आहे आणि याच्यावरून जर आपण ग्राफ काढला स्ट्रेट लाईन पासिंग थ्रू द ओरिजिन त्याचा जो स्लोप आहे ग्राफचा the 4 pi square divided by gm, that is constant. Next is escape velocity. So let us read these points. Minimum velocity with which a body should be projected from surface of planet to reach to infinity is called the escape velocity. मिनिमम वेलोसिटी जी आहे जी लागते की जेणेकरून ती बॉडी आहे ती आपण प्रोजेक्ट करतो फ्रॉम द सरफेस ऑफ प्लॅनेटच्या सरफेस पासून which reach to infinity is called as escape velocity. It is given by Ve is equal to under root twice gm upon r. So greater the value of escape velocity from a planet, denser will be its atmosphere. Value of escape velocity of the earth is, everyone knows, 11.2 km per second. For moon Jupiter it is given, and there is no atmosphere on moon because the RMS velocities of the molecules are greater than the escape velocities. If the velocity of a satellite is increased root 2 times or by 41.4%, it escapes out from the earth because its velocity becomes greater than the escape velocity. So if we consider simply the escape velocity म्हणजे काय तर कमीत कमी अशी velocity जी ती बॉडी प्रोजेक्ट करते सरफेस पासून त्या प्लॅनेटच्या आणि जी इन्फिनिटीला रीच होऊ शकते. प्लॅनेट टू रीच टू इन्फिनिटी, its value V is equal to under root twice gm by r. Next is geostationary satellite. So geostationary satellite, if we consider the communication satellite, is also called as geostationary satellite. It appears to be stationary when observed from the earth because its period is same as that of the earth. It is also called as geosynchronous satellite since it coincides with the spin of rotation of earth. So simply talking, so geostationary satellite is nothing but the satellite which is synchronized with the rotation of earth. So a satellite whose time period is same as that of the time period of the earth above its own axis, that is 24 hours. Its height is nearly 36,000 kilometers above the equator and 42,000 kilometers from the center of earth. It is a satellite moving in equatorial plane west to east. It is used for communications such as television, broadcasting, weather forecasting, military purpose, to study cosmic rays and solar radiations. Geostationary satellite म्हणजे काय तर असा सॅटेलाइट किंवा त्याला आपण कम्युनिकेशन सॅटेलाइट म्हणतो की जो आपण सेट केलेला आहे कुठे तर पृथ्वीच्या वर आपण त्याला सेट केलेलं एका पर्टिक्युलर डिस्टन्सला, ज्याला आपण जिओसिंक्रोनस सॅटेलाइट असे म्हणतो. त्याचं रिझन काय तर तो कोइन्साइड करतो कशाशी, स्पिन ऑफ रोटेशन ऑफ अर्थ. म्हणजे जर फॉर एक्झाम्पल आपल्या वर जिओस्टेशनरी सॅटेलाइट असेल आणि आपण त्याला 24 तासात कधीही बघितले तर तो आपल्याला त्याच ठिकाणी आपल्या डोक्याच्या वरच दिसणार. त्याचं कारण काय तर आपल्या पृथ्वीचा फिरण्याचा जो वेळ आहे टाइम पिरियड आणि जिओस्टेशनरी सॅटेलाइटचा आहे तर तो सारखा आहे. त्याच्यामुळे कधी जरी आपण त्याला बघितलं तर तो आपल्याला आपल्या डोक्याच्या वरच दिसणार. तर त्याची जी हाईट आहे तर ती इक्वेटर आणि सेंटर ऑफ अर्थ साठी दिलेली 36,000 किलोमीटर अँड 42,000 किलोमीटर. वेगवेगळ्या पर्पजेस साठी आपण त्याला यूज करतो, त्याचे ऍप्लिकेशन्स आपण बघितलेले आहेत. सो लेट अस मूव टू द नेक्स्ट पॉइंट, that is weightlessness. So feeling of weight is due to the reaction force exerted by the surface of the earth. The weight of person is maximum on the surface of the earth. The astronaut in an orbiting satellite feels weightless. The apparent weight of the body is 0, but actual weight can never be 0. So you know that weightlessness in a satellite, maybe you have observed in Discovery Channel or YouTube videos that how that weightlessness is there. So it is because feeling of weight is, first we have to know how we can feel the weight. So feeling of weight is due to the reaction force exerted by the surface of the earth. The weight of person is maximum on the surface of the earth, but as in the satellite, what happens? The astronaut is in an orbiting satellite feels weightless. The apparent weight of the body is 0, but actual weight cannot be 0. So apparent weight of the body is nothing but actual weight of the body minus weight of the body due to acceleration. So that weightlessness state is because we are moving away from the earth and it is in the satellite, so that body feels weightlessness. So weightlessness is observed only in an artificial satellite, but it is not observed on a natural satellite like moon because it has its own gravity. So in case of artificial satellite, we can feel that weightlessness. In natural satellite like moon, so as that moon is having its own gravity, so we are not feeling that. So freely falling body. So a body is said to be a freely falling body when it falls under the effect of gravity of the earth alone and the effect of all other forces is negligible. A freely falling body is one which falls with the acceleration due to gravity. So this point we have discussed already. आपण हा पॉइंट मगाशी चेक केला की ऍक्सेलरेशन ड्यू टू ग्रॅव्हिटी जो पॉइंट आहे तो आपण कसा कन्सिडर करतो तर त्याच्यामध्ये फक्त ग्रॅव्हिटी कशाची पृथ्वीची तर ती फक्त तो फोर्स ऍक्ट केला पाहिजे and other effects or other forces is negligible. So a freely falling body is one which falls with the acceleration due to gravity. Okay, so we have covered different points related to the gravitation, some basic terms and some equations which we are using to see the MCQs that are nothing but numericals. So let us check these numericals one by one. So first one is the weight of a body at a distance 2r from the center of the earth of radius capital R is 2.5 Newton. If the distance is 3r from the center of the earth, the weight of the body will be, means if we are considering two cases where the distance varies. So as we know that the relation between F and R, so we are considering two cases, that is F1 and F2. Related to that values are R1 and R2. So equation becomes, after adjusting, that is solution F2 upon F1 is equal to R2 by R1, it's a square, but the values we know. So after putting the values, we are getting the answer, that is 1.1 Newton. So let us move to the next one. When bodies of masses 1 kilogram and 25 kilogram are separated by a certain distance, the resultant gravitational field in between them is 0 at a point which is 1 meter from 1 kg, then the distance between them would be. Now in this case we have to consider the values, that is capital M1 and M2 as 1 kg and 25 kg. Here the condition is that the resultant gravitational field in between them is 0 at a point which is 1 meter from 1 kg. Okay, so then the distance between them would be. So we are just considering the value as x and r minus x, that is the value we have considered, and if we put that values we can get the answer that r is equal to 6 meter. We move to the next one. Acceleration due to gravity at Earth's surface is 10 meter per second square. The value of acceleration due to gravity at the surface of a planet of mass 1/5 and radius 1/2 of the Earth is. Means what? So acceleration due to gravity we are considering for numerical value, that is simplification 10 meter per second square. What are given things? The value of acceleration due to gravity at the surface of a planet of mass 1/5 and radius 1/2 of the Earth is. Means if we change the value of acceleration due to gravity and value of radius, then what are the changes? So simply we are using the equation, that is g2 upon g1, which equal to m2 upon a1 into r1 by r2 its square, which is equal to 1 by 5 into 4 by 1. How we can get it? So 1 by 5 is nothing but it is a 1/5. Then it is a 4 by 1, so it is 1/2, so it becomes square, that is 1/4. 4 comes in the numerator, and after solving this, as we know the value of g we have considered as 10, so it is 8 meter per second square. So 8 meter per second square is the answer for this MCQ. Next, a body of 200 kg weight is lying on the surface of the earth. Find its weight at a place capital R above the surface of the earth. The radius of the earth is, we are considering capital R. So simply what we are considering the value, that is R divided by R plus H, its square. After putting the values, we can get the answer as 50 kg weight. So let us move to the next one. Two planets are of the same material, but their radii are in the ratio 2:1. So material is same, but the radius are different, that is 2:1 ratio. Then the ratio of accelerations due to gravity on those two planets is. So we have to determine the ratio of acceleration due to gravity. So if you consider the density, it is the same. The radius ratio is 2:1, and we have to determine simply the ratio of g1 to g2. So solution is equation we know, that is g1 upon g2, which is equal to rho1 upon rho2. As same material we are considering, so density is same, so it becomes 1, and r1 by r2, that is 2:1 we are considering, so it becomes simply 2:1. Same thing or same ratio, we are getting the ratio of acceleration due to gravity on those two planets is 2:1. So let us move to the next one. If g is acceleration due to gravity on the surface of the earth having a radius capital R, the height at which the acceleration due to gravity reduces to g by 2 each. So first try to understand this. If g is acceleration due to gravity on the surface of the earth, means on the surface, value g of course, with a radius capital R, the height at which the acceleration due to gravity reduces to g by 2 each, means we have to determine the height by considering that at that particular height, that value of acceleration due to gravity becomes half. So for that we have to consider the equation. We know that is g2 upon g1, which is equal to r divided by r plus h, its square. As we have to determine the value of h, so there is difference between these two conditions, that is value of g at radius capital R and value of g at that particular height, which is g by 2. So we are writing this as g divided by twice g. Half second case means into 2 for first case. So g divided by 2g, which is equal to r divided by r plus h, its square. After solving this one, that is removing the square, here it becomes g cancels each other. 1 divided by root 2, which is equal to r divided by r plus h. So after simplifying this, we are getting the value as h is equal to r in bracket root 2 minus 1, that is option D, which is the answer. So we move to the next one. The depth from the surface of the earth where acceleration due to gravity is 20% of its value on the surface of the earth is. So given things, that is r is equal to 6,400 km. So once again we check the depth from the surface of the earth म्हणजे आपल्याला इथे काय करायचं आहे तर डेप्थ डिटरमाइन करायची. द डेप्थ फ्रॉम द सरफेस ऑफ द अर्थ वेअर कंडिशन काय आहे acceleration due to gravity is acceleration due to gravity किती आहे 20% of its value on the surface of the earth. म्हणजे सरफेस अर्थचा जर सरफेस कन्सिडर केला तर तिथे जी व्हॅल्यू आहे जी ची त्याच्यापेक्षा 20% acceleration due to gravity ज्या डेप्थला आहे ती डेप्थ आपल्याला डिटरमाइन करायची. रेडियस आपल्याला दिलेली आहे दॅट इज r is equal to 6400 किलोमीटर. तर आपण हे इक्वेशन बघितलेली दॅट इज acceleration due to gravity for depth that is gd is equal to g into 1 minus d upon r. तर gd जी आहे तर ती डेप्थची व्हॅल्यू आपल्याला किती दिली 20%. 100%च्या 20% म्हणजे 0.2 which is equal to 1 minus d divided by 6400. So we are putting the value and after solving we are getting the answer as 5120 kilometer, that is depth from the surface of the earth where acceleration due to gravity is 20%. So we are getting the answer as 5120 kilometer. Next, radius of earth is around 6000 kilometer. The weight of body at height of 6000 kilometer from earth's surface becomes. So once again check, radius of the earth is around, so radius is given near about 6000 kilometer for numerical purpose. The weight of body, so we have to determine the weight of body at height of 6000 kilometer. So we are adding more 6000 kilometer height from the earth's surface becomes, and options are half, 1/4, 1/3, no change. So for that we have to take the ratio for this, that is W2 by W1 which is equal to R divided by R plus H. It's a square but the value of H is nothing but same as that of radius of earth, so it becomes R divided by R plus R. It's a square which is equal to 1/4. So if we just shift the things, so we can get W2 is equal to W1 by 4, or simply it is the 1/4, and we get the answer. So we go to the next one. Two satellites of masses 50 kg and 100 kg revolve around the earth in circular orbits of radii. So values of radius are respectively 9r and 16r, where capital R is the radius of earth. The speeds of the two satellites will be in the ratio. So we have to consider and we have to determine the ratio for that. So two satellites of masses दिलेले 50 kg आणि 100 kg revolve around the earth circular orbit मध्ये revolve करतायत. त्यांचे radius दिलेले आहेत 9 into r 16 into r. r म्हणजे काय तर radius of the earth आहे. तर त्यांचा जो स्पीड आहे त्या दोन सॅटेलाइटचा, तर त्यांचा रेशो काय आहे हे आपल्याला चेक करायचे. सो इट रिलेटेड टू द व्हॅल्यू ऑफ vc, that is critical velocity. So vc1 upon vc2 is nothing but simply under root r2 by r1. So we have to know this relation. जर आपण या व्हॅल्यूज पुट केल्या, व्हॅल्यू ऑफ r1 9 into r, व्हॅल्यू ऑफ r2 16 into r. So we are just converting that and we are getting the answer as 4/3. So we move to the next one. A satellite of mass m is at a distance small r from the center of the earth. Another satellite of mass twice m is at a distance of 2r from the earth's center. Then their time periods are in the ratio. आता टाइम पिरियडचा जो रेशियो आहे त्याच्यासाठी आपण काय केलं तर इक्वेशन बघितलेलं आहे, t square is proportional to r cube. तर ते इक्वेशन ज्याला आपण केपलर्स लॉ त्याचं जे इक्वेशन आहे तर ते इक्वेशन यूज करतोय. तर इथे काय सांगितलंय, ए सॅटेलाइट ऑफ मास m इज ॲट अ डिस्टन्स r फ्रॉम द सेंटर ऑफ अर्थ. सेंटर ऑफ अर्थ पासून एक मास m चा सॅटेलाइट आहे, तर ते r डिस्टन्स वर आहे. अजून एक सॅटेलाइट आहे त्याचं मास आहे ट्वाइस m, आणि तो ट्वाइस r डिस्टन्सवर आहे अर्थ सेंटरपासून. तर टाइम पिरियड्स मधला रेशो त्यांचा काय असणार. सो we know that t square is proportional to r cube, t2 upon t1 which is equal to r2 upon r1. So we are adjusting this term, that is square and cube root, square and cube, so it becomes 3 by raised to 3 by 2. So it is twice r and r. We are putting the values. After adjusting the terms, we are getting it as 2 by root 2 divided by 1, and ratio is nothing but t1 by t2, which is equal to 1 divided by 2 root 2. It is option D, 1 is to 2 root 2. So we move to the next one. Two satellites are orbiting around close to the Earth in circular orbits with same period. So time period is same, and they are orbiting close to the Earth. One of them is 100 times greater in mass than the other. Their radii of orbits are in the ratio. So try to understand this. Two satellites are orbiting around close to the Earth in circular orbits with the same period, time period is same, and masses are different. So one of them is 100 times greater in mass than the other, then the radius of the orbits in the ratio. So radius and time period if you consider, so time period is same. So simply we are getting the radius ratio as 1:1. There is a independence of mass relative to this case. So answer is 1:1, which is correct one. Next, if the escape velocity of the Earth is 12 km per second, then what would be the new escape velocity if the radius of the Earth shrinks to 1/4 of present value such that its density does not change? So here what we are considering, if the escape velocity of the Earth is 12 km, then what will be the new escape velocity? नवीन escape velocity ची व्हॅल्यू काय असेल जर अर्थची रेडियस ही श्रिंक झाली, म्हणजे अर्थची रेडियस कमी झाली, किती झाली 1/4, म्हणजे आहे त्याच्या 25% झाली ऑफ प्रेझेंट व्हॅल्यू. डेन्सिटी आपण तशीच कन्सिडर करतोय, तर त्याच्यासाठी आपण एस्केप वेलोसिटीचा रेशो घेतो ve2 upon ve1 which is equal to r2 divided by r1 in root 2 by rho 1, that is density which is same. इथे 1/4 केस आपण कन्सिडर करतोय, so it becomes 1/4. Shift ve2 here, so ve2 is equal to ve1 upon 4. ve1 म्हणजे escape velocity किती दिलेली आहे 12 km per second, so 12 by 4, simply we are getting 3 km per second. So the answer is 3 km per second. And next, the radius of the Earth is capital R for a satellite to appear stationary. It must be placed in orbit around the Earth at a height near about. So we have to set the satellite. For that you have to know the value of geostationary satellite height. It is 36,000, but accurately it is 35,870 km. So simply we are taking the ratio, that is h divided by r is equal to 35,870 divided by 6380, which is nothing but radius of the Earth, which is equal to 5.62. So MCQ like this, we have to know the basic values. So I think we have covered these 2 points. First point is the basic terms and equations, and second is different MCQs or numericals related to that equations. So we conclude here. Thank you for listening and thank you for watching this video. Thank you very much.